Dear children, we are starting with the section on section B. Okay, you know that according to our syllabus, we have section B for 15 marks, 1 5. Okay, where we have to cover up three chapters, that is on vectors, three-dimensional geometry, and application of integrals. Okay, from where vectors you will be having as per the syllabus which had been given now, like as per reduction and all has been done. We have vectors for 5 marks, three-dimensional geometry for 6 marks, and application of integrals for 4 marks. Okay. So when we talk about vectors, like what are things we have to learn in vectors are, that is regarding the basic ideas regarding vectors is to be learned. Okay, especially focusing on learning about what is vector and what is scalar, because you know that there are two physical quantities which are divided into physical quantities are divided into two. One is known as a vector quantity and the other is known as a scalar quantity. Okay, so here when we talk about vectors in mathematics, only the mathematically done concepts, that is what we have to learn, and not much into theory of that, as though you learn in physics and all. You don't have to learn about much of the theory part. Just brushing up the ideas of what we have to do as a basic ideas in vectors. So we have to learn about point number 1, what is vector as a directed line segment. Second one, we have to learn about the magnitude and direction of a vector. Then thirdly, we have to learn about the different types of vectors. There are so many types of vectors, but here we have to focus only on equal vectors, unit vectors, and zero vector. Okay, and then we have to learn about what is a position vector. Okay, that's an important point. And also we have to know about the components of a vector. When we talk about components of a vector, we consider the three-dimensional space, the three-dimensional coordinate axis we take, that is the x-axis, y-axis, and z-axis, and vectors in 2 dimension as well as 3 dimension also we have to learn. And then we consider the mutually perpendicular axis. That is the x with respect to the three mutually perpendicular axes, that is OX, OY, and OZ. We talk about the unit vectors also, I, J, K as the unit vectors, which is taken along the x-axis, y-axis, and z-axis, and expressing and how to express a vector in terms of these unit vectors along with the components. Mostly you might have heard in 2 dimension we express it in the form of xi plus yj. Similarly, here in 3 dimension, when we consider, we express it in the form of xi plus yj plus zk, where xyz will be a point which will be considered with respect to the 3 coordinate axis. Okay, and also we have to know about how the operations on vectors are done, that is the sum and difference of vectors as well as the scalar multiplication of vector. All these are actually ideas which you have learned in physics also, but still we have to go through this in our section B part. Okay, and then we have to cover up the section on the scalar product of vectors as well as the cross product or the vector product of vectors. Along with that, we have to learn its properties also. Okay, so what they have told is that they don't ask any geometrical theorems, because in your textbook when you go through you will see that there's so many geometrical theorems proved and all. It will not be asked for the exam. Only these much concepts are to be focused, and that too they are given that it is only for 5 marks. Okay, so 5 marks means probably the question can be like this, like one 4-mark question and one mark question, or it can be in such a way that it can be two 2-mark question which can be given, two 2-mark question and one 1-mark question. Okay, so like that it can be given. Okay, so let us start with the section on this vectors, section B, which according to your textbook, okay, which according to your textbook, that is volume 2 textbook, it appears on page number 1135 of your textbook. Okay, page number 1135 of your textbook, because some of the basic things we have to know from the textbook itself. Going through the textbook is more beneficial when we learn about this basic things and all, and then you can work out on the questions based on that also. Okay, so the basic concepts which you have to learn in vectors. So first you have to know that the physical quantities are divided into two. One we call it as the scalar quantity and the other we call it as a vector quantity. And when we talk about scalar quantities are the one which has got which has both magnitude and direction. Okay, I mean that is what which has only magnitude and direction. That is what we call it as a scalar quantity. And vector quantity is the one which has got both magnitude and direction. So scalar quantities, when we mention about scalar quantities, it has only magnitude. Okay, it has only magnitude and no direction. Only magnitude and no direction. There are so many examples which you can cite out. You might have learned about so many examples also, especially speaking about the length, the distance, the speed, etc. All this has got only magnitude but no direction. Okay, so that is what we call it as the scalar quantity. And when we talk about a vector quantity has got both magnitude as well as direction. Both magnitude as well as direction. So when we talk about this vector quantities, I think the examples which will come in your mind as you have learned in physics, it will be like velocity, acceleration, displacement, etc. All these has got both magnitude and direction. Even force, momentum, etc. All these has got both magnitude and a direction. So to specify a vector or to define a vector, what all things are needed? Okay, what all things are needed is that the first thing we need is that we need to know about the direction. We need to know about the magnitude and the unit in terms of which it will be measured. What will be the unit we will be using, because you know that when we use the displacement, what will be the unit used, when we use the acceleration, what will be the unit used, like that. So it will depend on three factors. That is what is given on page number 1135 in the definition and the basic, under the heading on basic concepts, section 1.1, some basic concepts. Scalars, I will read out that. Scalars, a quantity which has only magnitude and no direction, is called a scalar quantity or simply a scalar. And examples of scalars are length, distance, speed, etc. To specify a scalar, two things are needed. One is the unit in terms of which it is measured, and the second one is a real number. That is a real number which can be either positive, negative, or even zero. Okay. Now talking about vectors, a quantity which has magnitude as well as direction is called a vector quantity or simply a vector. Examples of vector are displacement, velocity, acceleration, etc. To specify a vector, three things are needed, as I've told. One is a unit in terms of which it is measured, and the second one is a real number, and the third one is a particular direction. Okay, and they also have given a figure along with that, a portion of a straight line that has to be marked in your textbook also, a portion of a straight line whose two endpoints are distinguished as initial and terminal is called the directed line segment. So actually speaking, vector is a directed line segment. Okay, vector is a directed line segment in the sense that a portion of a straight line whose two endpoints are distinguished as initial and terminal is called a directed line segment. Okay, so that also I will show you how to do that vector thing, how to be drawn and all. But for the timing, I'll just read it out what is given here. So there's a figure which is given, the directed line segment whose initial point is A and the terminal point is B is denoted by the symbol arrow, one forward arrow, we put it on the top of this AB. We read it as vector AB. Okay, the directed line segments AB, vector AB and vector BA are different. AB means it will be from A to B. A will be the initial point and B will be the terminal point. Whereas when we say BA, vector BA, B will be the initial point and A will be the final point. Okay, that is how it will be. So the two endpoints of a directed line segment are not interchangeable. The directed line segment is positive or negative according as it is along the direction or to the opposite direction of the line segment. Every directed line segment has length as well as direction. Actually, that is why we put it in a single term. Actually, now hereafter when we define vector, no, we say that vector is a directed line segment. Okay. Now moving on to the next page, they are talking about the length or the magnitude, the distance between the 2 points A and B. Okay, that distance is what we call it as the length of the directed line segment AB. it will be denoted as modulus of, we read it as modulus of vector AB. Modulus means it is a length. That is how we usually learn. Okay. So modulus of vector AB. We know that when we talk about vector BA and vector AB, both modulus are the same. Whether it be AB or BA, the modulus is the same. Modulus of vector AB is equal to modulus of vector BA. Okay. And the line of which the directed line segment is a part is called a line of support. That you just know about that. Then knowing about the representation of vectors, how can we represent a vector? Since a vector has got magnitude as well as direction, it can be represented by a directed line segment, vector AB. Thus, a vector is determined by 2 points A and B, such that the magnitude of the vector is the length of the segment vector AB and its direction is from A to B. Thus, a vector is written as vector AB. A is called, where the point A is called its origin, or we term it as, actually we call it as the initial point, and B is the terminal point or the end point. Vectors are also denoted by single letters with an arrow or a bar over its head. Thus, a small letter can be used for that. Thus, vector A may be written for the vector AB, and we express this by writing vector AB is equal to vector A. And also from that, we talk about the modulus of a vector. The length of the line segment AB is called the modulus of the magnitude of the vector AB. The modulus of the vector AB is equal to, it is written in that way, modulus of vector AB. Okay, that is how. So these basic concepts I will show you how it is done, and based on that we have to talk about the position vector as well as the direction cosines of a vector as well as the types of vectors. Actually, this concept of direction cosines occur in 3-dimensional geometry, but I can tell you here about this concept of direction cosines and direction ratios also. Okay, so let me get back to my whiteboard to explain how this is done, how the concept of vector is done, the further concept. Okay. So when we talk about the vector, I have told that suppose it is vector AB I want to mark. It is like this. The direction is shown in this way. So vector BA means, when differentiating these two, vector BA means BA can be represented. If it is the same way I have put it in AB itself, I am marking BA means I can put the arrow like this. BA can be represented like this. So a vector is a vector directed line segment. That is what I told. So remember the points which we have learned. It is a directed line segment. It has got a magnitude as well as direction. The magnitude we write it in the form of modulus of vector AB. That is how we represent. Either like this, or if you put it like this, AB and a bar over there, that will also be represented as the magnitude, okay, or the modulus of the vector. Now talking about the position vector, okay, talking about the position vector. When we talk about this position vector, here we can consider the vector to be in the 3-dimensional coordinate. Okay, when we talk about the 3-dimensional coordinate, we have the x-axis, the y-axis and the z-axis. It may not be the same way as you have done in physics and all. Will be representing here. It is taken like this, x, y and z like that. This is the origin you have. Okay. Now consider any point P. If it is 2-dimensional, I will be representing it as x, y only. Here I am talking about 3-dimensional. So consider any point P x, y, z with respect to the 3 coordinate axes, x axis, y axis and z axis. Now you join this OP. I'm joining this OP. Okay, so if it was in 2-dimension, remember it is like this. Suppose if we consider any point P x, y, and this is the origin I am having, I'll be joining this, means this is the way I'll be getting when we join this figure. It will appear like this. From P, I'll be dropping a perpendicular. This is PM, and you know that this will be taken as x and this will be taken as y. And OP is the length, so let us take it as equal to R. This is a 2-dimensional concept. Now we are learning about the 3-dimensional concept. So I have taken P as x, y, z as any point on the or with respect to the three coordinate axis x, y and z axis. Okay, so I am representing its direction. Let it be vector OP, which is equal to vector R. I am putting it in that way. Okay, so now what to do with this position vector Z? Position vector of any point P, X, Y, Z is always considered with respect to the origin. That is, we talk about the position vector in terms of the point P in terms of vector OP. Always the position vector is pointed out in terms of the origin only. That is with respect to the origin only. That is what you see in page number 1136. Okay, all these are definitions that you can mark in your textbook. Okay, position vector of a point. Let P be any point in space having coordinates x, y, z with respect to some fixed point O. Okay, where O is the origin. Then the vector OP having O as its initial point and P as its terminal point is called the position vector of the point P with respect to the origin O. The vector OP is usually denoted by R. And note that modulus of vector OP means it is equal to. So how will we find out the modulus? Here also in case of two-dimensional geometry, you know that the modulus or the length of OP. How will we work out the length of OP? Length of OP is equal to x square plus y square. We use the Pythagoras theorem. Similarly, modulus of vector OP. How do we write the modulus of vector OP is equal to root of x square plus y square plus z square. That is how we find its length. So, modulus of vector OP will be equal to root of x square plus y square plus z square. That is what is given. Note that modulus of vector OP is equal to root of x square plus y square plus z square, or R can be written as equal to root of x square plus y square plus z square. So, when we talk about this position vector, always remember that the position vectors, so the position vectors are always represented with respect to the origin. Suppose if I say position vector of the point A means you have to remember that it should be written in the form of vector OA. If I say position vector of the point B means you have to remember that it should be written as equal to vector OB. If I say position vector of the point X means you have to write it as vector OX. If I say position vector of the point Y means it will be written as OY, like that. So always the position vector we talk with respect to the origin. Okay, that is a concept of position vector. Okay, so I hope this much you understood, like the definition as well as how to find the modulus and then how to find the position vector of the point also. Okay, now we go on with the major concept which we have to learn, that is also required in three-dimensional geometry also, that is explaining about the direction cosines. It's a very important term, direction cosines and direction ratios. It's a very important term. Okay, for that we consider the same figure itself, direction cosines and direction ratios. So we consider the same figure in the sense that we draw the figure in such a way with respect to the three coordinate axis. This is like the origin. This is taken as x axis, this is taken as y axis, and this is taken as z axis. Okay, I am considering a point P, P, X, Y, Z. From O, I join this OP. Okay, now if this vector OP, I am marking vector OP, if this vector OP makes an angle, okay, if this vector OP makes an angle alpha with a positive direction of x-axis, beta, an angle beta with a positive direction of y-axis, and an angle gamma with a positive direction of z-axis. Okay, so let the vector OP makes angle alpha with a positive direction of x-axis, beta with a positive direction of y-axis, and gamma with a positive direction of z-axis. Then this angle alpha, beta and gamma, they are known as the direction ratios. We call by the name of direction ratios. I'm sorry, these are called by the name of direction angles, not the direction ratios. These are named as the direction angles, and the cosine of these angles, that is what we write it in the form of cos alpha, cos beta and cos gamma. They are known as the direction cosines. Once again, if a vector OP makes an angle alpha, beta, gamma with a positive direction of x, y and z axis, the angle alpha, beta, gamma are known as the direction angles. Okay, and the cosine of these angles, cos alpha, cos beta, cos gamma, they are known as the direction cosines. And what do you mean by this direction ratios? Direction ratios they are merely numbers. Okay, they are three numbers which are proportional to this direction cosines. Three numbers A, B and C, that is how they are denoted. Three numbers A, B and C which are proportional to this direction cosines. And one more thing is that these direction cosines are denoted by the letters L, M and N. That means we have L is equal to cos alpha, M is equal to cos beta and N is equal to cos gamma. So I have told that alpha, beta, gamma are the direction angles, cos alpha, cos beta, cos gamma, the direction cosines denoted by L, M, N, and the direction ratios are A, B and C. So L is equal to cos alpha, M equal to cos beta and N equal to cos gamma. Okay. Now if we take a part of the figure, that is the three-dimensional figure, which is given on page number 1137 of your textbook. With respect to the x-axis, you know that alpha is an angle made by vector OP with a positive direction of x-axis. Okay, so this part OA will be taken as equal to x, and here OP is taken as equal to vector r, so that cos alpha will be written as equal to x by modulus of vector, because we have to take the length. So it will be taken as x by modulus of vector r, which is equal to x by r. Or from this we can write cos alpha is denoted by L, no? So it will be written as L is equal to x by r, which implies x is equal to LR. Okay. Similarly, if we consider the other parts, that is triangles which are given in the form of OBP. Here it is OAP, OBP as well as OCP with respect to the y-axis and the z-axis. Okay, so what we get is that we get the conclusion that y will be taken as equal to MR and z will be taken as equal to NR. Okay, so the coordinate of x, y, z in terms of the direction cosines as well as the length of the vector, it will be taken of the form LR, MR, NR. Remember, L, M, N are the direction cosines. Direction cosines means cosine of the angles made by the vector OP with the positive direction of x, y and z axis. Okay, so x, y, z will be written in terms of L, R, MR and NR. Okay, and there is a major result. Okay, there is a major result connecting this direction cosines, which you have to know is that the value of L square plus M square plus N square is equal to 1. This is a major result connecting the direction ratios. Okay, so you don't have to learn the proof and all, just learn the result only. L square plus M square plus N square, the value is equal to 1. Okay, and when talking about, as I said, when talking about the direction ratios, so I said three numbers A, B, C which are proportional to the direction cosines. Okay, three numbers A, B, C which are proportional to the direction cosines is what we call it as the direction ratios. That is, we have L by A equal to M by B equal to N by C, where this A, B, C are known as the direction ratios. Okay, so if we equate, this is equal to, suppose this is equal to a constant K. Three numbers which are proportional to direction cosines, as we write it as equal to direction ratio. So if I put it as equal to K, then L is equal to A into K. Similarly, M can be written as what? B into K, and N can be written as equal to C into K. Now what we do is we will substitute there L square plus M square plus N square is equal to 1. So what we get is A square K square plus B square K square plus C square K square is equal to 1, where K square into A square plus B square plus C square is equal to 1, or K square is written as equal to 1 by A square plus B square plus C square. Okay, or K will be written as equal to what? K will be written as 1 by root of A square plus B square plus C square. So when we are writing this L, M and N in terms of AK, BK and CK, okay, this K can be substituted with that values, so that it will become, the result will become fully in terms of the direction ratios, because there will be question connecting that direction cosines will be asked, you will be given the direction ratios and you will be asked to write the direction cosines. So L will be written as, see, L is equal to A into K. So L will be written as A by root of A square plus B square plus C square. M is equal to B into K. So it will be written as B by root of A square plus B square plus C square. And N will be written as equal to CK. So C by root of A square plus B square plus C square. So this is a major relation connecting direction cosines and direction ratios. That is, direction cosines are of the form LMN and ABC are the direction ratios. So we get the result in this way. Okay, this is the result connecting direction cosines and direction ratios. So this is a concept of direction cosines and direction ratios, which is given on page number 1137 of your textbook. So I'll just read it. Okay, I'll just read it in the sense that that section which is starting on page number 1136, direction cosines of a vector. You can look into the figure also. Let P be any point in space having coordinates x, y, z. With respect to the origin O, if the vector OP or vector R makes angle alpha, beta and gamma with a positive direction of x, y and z axis respectively, then alpha, beta and gamma are called its direction angles, and the cosine of these angles, okay, cos alpha, cos beta and cos gamma are called the direction cosines of the vector OP. All these are to be marked in the textbook. Okay, you can learn it from the textbook itself. These are usually denoted by L, M and N. So you have L is equal to, that you mark it in a box and keep it. L is equal to cos alpha, M equal to cos beta and N equal to cos gamma. And the figure which I explained, okay, that is also given. There's a three-dimensional figure as well as a part of that is extracted from that. So with respect to the x-axis, from that they have found out the relation also. That is, x can be written as equal to LR. Similarly, y can be written as equal to mr and z is equal to nr. The numbers LR, mr and nr, which are proportional to the direction cosines of the vector r, are called the direction ratios of the vector r. And they are usually denoted by what? A, B and C. So A is equal to LR, B is equal to MR and C is equal to NR. Okay. So that is also, you can mark it and keep. And the remarks also, they are very important. The coordinates of the point P can be written as LR, MR and NR. And from three-dimensional geometry, okay, three-dimensional geometry is, they say this result on direction cosines, okay. The proof you don't have to learn. So just learn the result only, L square plus M square plus N square equal to 1. And with the help of that, they have worked out the value of R also, which I showed it by K. Okay, R is equal to root of A square plus B square plus C square. So that is written as root of sigma A square. And so L can be written as, that is what I showed here. L is equal to A by root of A square plus B square plus C square. M is equal to B by that value, root of A square plus B square plus C square, and N is equal to C by root of A square plus B square plus C square. Okay. Now moving on to the type of vectors. Which all type of vectors you have to know is that about the zero vector. Zero vector means a vector whose magnitude is 0 is what we call it as a zero vector or the null vector. Okay. It is represented by the symbol. Over 0 you put that vector arrow. That will be the zero vector. Zero vector has no specific direction, or it can be regarded as having any direction. Okay. In this case, the initial and the terminal points coincide. Thus, the zero vector may be represented by the line segments, vector A, vector B. Like initial and terminal points will be the same. Okay. That is what we call it as a zero vector. Okay. Then you have to know about the unit vector, a vector whose magnitude is 1, unity. Okay. modulus of vector AB is equal to 1 or modulus of vector A is equal to 1. It is what we call it as a unit vector. If vector A be a vector whose magnitude is A, then the corresponding unit vector in the direction of vector A is represented A cap, that is over A. So if it is small letter A, you are using over A, over the small a, you put a cap symbol. Cap symbol means something like this. Okay, that is what we call it as a unit vector. Okay, and then comes the equal vectors. Equal vectors, two vectors, vector A and vector B are said to be equal. Means we write it as vector A is equal to vector B. If they have the equal magnitude and the same direction, then we call it as the equal vectors. Okay, and collinear vectors, two or more vectors are said to be collinear. Means if they have the same or parallel support, that is if they lie on the same line, that is what we call, and coplanar vectors which lie on the same plane. Okay, and I don't know whether you have learned about finding this A cap. For any vector A, you can find the unit vector in terms of the vector. A cap is equal to A cap, this is the formula you use for that. A cap is equal to vector A by modulus of vector A. That is also one formula which you can use there. Okay, A cap is equal to vector A by modulus of vector A. Okay, that you can remember. And the basic idea for proving the vectors to be collinear, that is the basic idea which you can use is that if you are given two vectors, vector A and vector B, for proving them to be, there are many methods to prove that they are collinear, but the basic idea of proving to be collinear is that if one vector can be expressed as a scalar multiple of the other, then we say that the vectors are collinear. When we talk about the scalar multiplication of vector, no, we will tell that, but still you can remember at this point that is two vectors are said to be collinear or two vectors are said to be parallel, means if one vector can be expressed as a scalar multiple. Scalar multiple means if suppose vector A can be written as k times into vector B, where k being any scalar, k can be positive or negative also. So that is what we call as a scalar multiple. Okay, now talking about the negative of a vector which occurs on page number 1138. Negative of a vector means having the same magnitude, okay, as of the given vector, but direction is opposite. That is what we call it as a negative. For example, for AB, if AB is a vector we are having, then minus BA will be the negative of the vector. Okay. And then talking about the vector algebra, we don't have to learn the theory concept and all, just to know how the vector algebra is to be done. Okay, we have addition, subtraction and the scalar multiplication. Addition, I think you might have learned the triangle law of addition and all. Okay, that's the same thing which is explained here also. Just to know that if 3 points AB, OAB are so chosen such that vector OA and vector AB are respectively represented as vector A and vector B. OB is defined as a sum of vector A and vector B, where C is equal to vector A plus vector B. So you might have learned in this way, if two vectors, vector A and vector B, are represented by magnitude and direction by the two sides of a triangle taken in the order, then the sum will be represented by what? The third side taken in the opposite order. Okay, that is what, just to know about that. And also the parallelogram law of addition. If two vectors, vector A and it is there in the textbook, you can look into that, page 1139, because we don't need any theory part. We have to just know about how vector addition is done in terms of the components only. Okay, so if two vectors, vector A and vector B, are represented in magnitude and direction with the two adjacent sides of a parallelogram, then the sum C will be represented by the diagonal of the parallelogram, which is co-initial with the given vectors. Okay. And properties of vector addition are there, they are commutative, associative and all that can be used only when we work out the questions. Like we have to learn it in terms of the components only, nothing to do with the basic idea of the theory concept. Okay, and the subtraction of two vectors which occurs on page number 1140, A minus B, vector A minus vector B, means you can also do it by what? Vector A plus of minus vector B, that is you can add it to the negative of vector B. Okay, and a representation of a vector in terms of position vectors of its endpoint, that is something which you have to know, how to represent a vector in terms of its position vector. Okay, for that look into the figure which is given on page number 1141, figure 1.11. Let PQ be a given vector with P as initial point and Q as end point. Okay, so PQ is a vector marked there with P as initial point and Q as a terminal point. Let OP and OQ, let vector OP and vector OQ be the position vectors of the point P and Q. Okay, using triangle law of vectors in triangle OPQ, we get vector OQ will be equal to, look into the figure, vector OQ will be equal to vector OP plus vector PQ. Okay, so that vector PQ can be written as what? Vector OQ minus vector OP. So vector PQ is equal to position vector of Q minus position. So usually when a vector is given, okay, for example, suppose you want to write about vector AB in terms of the position vector. Always remember that vector AB means in terms of the position vector, means position vectors are defined with respect to the origin. So if you want to write vector AB, look into the initial point and the terminal. Initial point is A and terminal point is B. Okay, so in terms of the position vector means we write it as position vector of the terminal point minus the position vector of the initial point. That is how any vector will be written. So if it is vector xy, then it will be written as what? Vector oy minus vector ox. So that is how it is defined. Okay, any vector means position in terms of the position vector, any vector can be written as position vector of the terminal point minus the position vector of the initial point. Okay, so that is what we have in page number 1141. And then a multiplication of a vector by a scalar, that is also explained there. That is nothing but when a vector is given, how to multiply with a scalar. I said no, scalar means you can have a positive scalar as well as a negative scalar. Suppose it is vector A given, you have to work out the value of 3A means multiply the whole thing which is given in terms of vector with 3, so that you can write 3A for that. Okay, and there comes some remarks also which are given there. In that the remark number 4, the point number 4 is important there, which I told here. It is A cap is equal to, A cap can be written as equal to vector A by modulus of vector A. That's a very important point which is given as remark number 4, this point. Okay, remark number 4 on page number 1141. And also the 5th point which I mentioned, the vectors vector A and lambda A are collinear, or if two vectors A, vector A and vector B are collinear, then we can find a suitable scalar such that B is equal to lambda into vector A. That is also a point to be marked in the textbook, which you have to note it down. They are important points. Okay, remark number 4 and 5, which is given on page number 1141. And then you have the properties of the multiplication by a scalar, that nothing to do with that. But then we have to know about how to write the components of a vector in a plane, which is given on page number 1142, components of a vector in a plane, section 1.2.11. Okay, you may see that Pxy is a point in the corresponding plane xoy, and ij be the unit vectors along x-axis and y-axis respectively. From P, you are drawn Pm perpendicular to Ox and Pn perpendicular to Oy. Then OM is equal to X and ON is equal to Y. With that figure you can find it using parallelogram law. All that is explained. But we don't need the theory part. Okay, just know how it is done. So along the x-axis is the unit vector I cap taken. Along the y-axis is the unit vector j cap taken. So how will you write the component of the vector? That's the most important one. Vector r can be written as, vector r is the position vector of the point Px comma y. Vector r will be written as xi plus yj. That is the component along the x-axis multiplied with the corresponding unit vector. So xi plus yj, like that. And when you have to find the length, it will be root of x square plus y square. Okay. So the same thing happens with the third, three-dimensional geometry also. If you take a point x, y, z. Okay. How will we write the component of the vector OP? It will be written as equal to xi plus yj plus zk, because we will have three unit vectors I, j and k taken along the x-axis, y-axis and z-axis. Okay. So vector r is equal to xi plus yj plus zk will imply modulus of vector r will be root of x square plus y square plus z square. Okay. So that also you can remember. And there are some results which are given on the same page itself, page number 1143. There's a theorem 1.212. if A is equal to A1i plus A2j and B is equal to B1i plus B2j are any two vectors, then A plus B is equal to, what you have to do, you have to add the corresponding components of I cap, and also you have to add the corresponding components of j cap, then you will get the result. That is how it is written. So the same thing happens for the components of a vector in 3-dimension geometry also, and you don't have to learn about that section formula, centroid of a triangle and all, because that is deleted from the topics which are reduced now. Okay, so this much is what you have, and along with that you may have to go through the example questions also. I will tell you which all example questions you may have to go through, as well as the exercise questions also, so that you can work on that. Okay, and then we will start with the section on dot product. After doing this, we will start with a section on dot product. Okay, thank you.